It's the Pythagorean theorem. Really? X squared plus y squared equals r squared. That's how simple the situation is. Now, step 2. Take the derivative with respect to, the question screams it all the way along the way. It screams what derivative we're talking about. Kilometers per hour. Kilometers per hour. And like most of the related rates questions in this section, it's time that's on the bottom. So we've got to take the derivative of x squared plus y squared plus r equals r squared with respect to time. Watch how it goes. Derivative of x squared is 2x. Derivative of the inside. 2y dy dt equals 2r dr dt. Now, when this question goes from difficult to easy is right as I explain what each of these things represents. X is how far the car is away from the intersection. dx dt is how fast the car is moving. It's how much the x is changing with time. Y is how far the police are from the intersection. By the way, the equations completely change as soon as the policeman turns the corner. We're just doing, they're on separate roads right now. dy dt is how fast the police car is going. R is how far away the police is from the car right at this particular moment. And dr dt is how fast the distance is closing, how much closer the police is getting to the car. Apparently all this information is in there. Well, let's find out what we're supposed to find. The speed of the car. Okay, someone who listened to all that and maybe has a chance at this. All of these things here, which one's the speed of the car? Or, in terms of variables here, what would the car speed be in terms of derivative? No. dx by dt. See, it's a nice question. There's a lot going on. It looks really complicated. But actually, all these things are really nice. This is dx dt. That's what we're after, is dx dt. So apparently, all the other stuff better be there. Well, there better be a way to find it. That happens in the odd question where, let's say they give you need r at some point in the question. It might happen in this one. I didn't read it carefully enough. And they want to give you x and y. You might have to do a little math to get the things you got to sub into. Well, let's look through. X would be how far the car is away from the intersection. They give us that. The car is 1.6 kilometers to the east. Just got to watch the sign here. It matters. Positive 1.6. dx dt. Speed of the car. Oh, that's what I'm after. See, that's what your physics teacher was on about writing this stuff with a question mark. See, when you get to dx dt, you're not freaking out. You know, oh, that's what I'm trying to figure out. So that's fine that I don't know that. The y. The y is how far the police car was north when the cruiser is 1.2 kilometers north. 2 times 1.2. dy dt is how fast the police car was moving. dy dt is, 120 kilometers an hour. Whoa, he is moving. R is the radius, the distance between the police and the car. Oh, they don't tell us that. Well, that's a problem, isn't it? They told us 1.2 over here. And they told us 1.6 over here. They didn't tell us the R, and I need it for the equation. I already gave this away, didn't I? What now? Yeah, so that's one thing that might have to come up in these questions is when you go to sub these things in, you might have to go back to the original equation and do a little subbing before you do the subbing. Yeah, some pre-subbing. So let's see. R squared equals 1.2 squared plus 1.6 squared. R squared equals, is it 2? Is it really that simple? Well, yeah. It's 3, 4, 5, I think, is it? It's a 3, 4, 5 triangle disguised. So the radius is 2. And dr dt. The distance between them is increasing at 40 kilometers per hour, making you believe that the police car is never going to catch him. The distance between them is increasing. The car's getting away. What is it about the question that tells you, oh no? Well, no, I guess we don't know yet. We don't know. The police car is going to come all the way down here. He's going to make the turn. And it really comes down to, what is dx dt? Is the car moving fast enough to get away based on all this? We can figure out the speed of the car based on all this. Maria, question? Maybe you'd like that better as distance. The distance between the two cars. I threw in R because of trig. R usually represents the distance, the hypotenuse of the triangle. So that's why I used R there. But maybe D is better. I also avoid D because when I go to take the derivative of D with respect to other things, my brain sort of quirks on dd by dt. You know, like it's a little too much. So the R is nice to say. It's the radius. It's how far away we are here. You know, like if there was a circle here, it's the radius of the circle. You know what I mean? Like so. You may not like that. Go with X, Y, and Z if you want. You know, if that works better for you. Is it good? Are you happy? Like you're not happy with how complicated it all is, but are you happy with the equation in the sense that, oh, I can do this now? The rest is pretty straightforward stuff because I've got all the numbers. That's the game in physics too. Do I have all the things for the equation I'm doing? If you have all the things, you're good. If you don't have all the things, well, you're in trouble, right? So I'll do some math here and you let me know how it goes. Something's wrong. And I don't know what it is. I don't let my brain work on it for a second. And I don't even know why I know something's wrong. X is 1.6, yes. dx dt, we're figuring out. Y is 1.2. dy, oh, dy dt. Oh, big moment. dy dt. What's happening to y? It's getting smaller. As this car drives on here. Negative 120. I don't know why I knew. It wasn't brilliance, because if I was brilliant, I wouldn't have missed it the first time. I knew because somehow I knew that had to come out to be negative so that this would be positive. And, you know, I could feel it. Again, not brilliance, just 20 years of doing these questions where I could feel what was about to happen. I don't even know if I have these numbers right. I'll check them in a minute, but I'll finish off the math anyways. 3.2 dx dt equals, oh, can I add those together in my head? 448. And then dx dt equals 448 over 3.2 dx dt. Oh, I don't know. This is asking a lot. 1, 12, 4, 0? Really? No, can't be. 448 divided by 3.2. 140. Okay, let me check the other numbers. 3.2 is right. 2 times 1.2 times negative 120. Negative 288. 160 plus 288. 448 divided by the 3.2. 140. Okay, I've got two conclusions here. One is the answer to the question. What is the speed of the car? Therefore, the speed of the car is 140 kilometers per hour. But I have another conclusion about this situation that they didn't ask about. Is the cop going to catch this person? He's not going to make it. Cruise is only going 120. Speed of the car is 140. And that's why this is sort of important calculation overall. Is like, oh, Now that we know this person's going 140, I'm going to have to crank it up a notch if he's ever going to track this guy down. Any questions about that? I tried to lay the hint. Did you catch the hint? Let's rewind the tape. This is my favorite question. Love this question. It's so complicated yet so simple, then so complicated and so simple. I guess it's one of those questions like the first time you do it, like, what is going on? This is the craziest thing I've ever seen. Second time you do it, like, oh, it's the same thing. Got to sub them in and get the signs right. Third time you're like, okay, I'm done practicing this. I got this. Okay. Any questions there? How many more do I got to do? Oh, I got 2 more to go. If you're wasting away. What's the word on break? Can we take a late break? Is that all right with you? Yeah, we can take a late break. Oh, your break's not till 35 anyways. We'll be close anyways. And then we'll take a long one. We'll negotiate when the other lesson's going to be. More time? Did I ask you? More time here? A spotlight on the ground shines on a wall 10 meters away. A man 2 meters tall walks from the spotlight towards the wall at a speed of 1.2 meters per second. How fast is the shadow on the wall decreasing when he's 3 meters? I don't know. Picture. Spotlight. Ground. We'll make the ground green today. There's the ground. Towards a wall. Okay, wall's got to be red because of bricks, right? Here comes a wall. A brick wall. Wall. A spotlight on the ground shines on a wall 10 meters away. Okay, 10 meters away. 10 meters. Got it. A man 2 meters tall. Man 2 meters tall. Now I gotta draw a man. What color will a man be today? Orange. He's Pumpkin Man. Here he comes. One man. Check. Oh, and then his shadow on the wall. Okay, here comes the light. Ready? I want to use yellow light here. Tell me if you can see it. I hope you can see it. Can you see the yellow for the light? I didn't even look to see if you said yes. I'll check in a minute. I'm going to taller wall here. And then, one last thing. I need on the wall. Just use a thicker pen there. Ooh. Shadow. Okay, how am I doing? Spotlight on the ground is 10 meters away. I got the 10 meters. A man 2 meters tall. Oh, I didn't get that in there. 2 meter tall man. Walks from the spotlight towards the wall at a speed of 1.2. How fast is the shadow on the wall decreasing when he is 3 meters from the wall? I'm going to add one more thing, and then I've got a really tough question to ask. Height of the shadow. All right, it's a tough question. There's 3 kinds of trig questions that come up, and so that's a weapon I'm using to teach this year, is to say, when trig questions comes up, there's basically 3 types that usually come up. The first is a simple angle situation that we saw earlier, where we just got an angle and 2 sides. It'll be sine, cos, or tan. We know how to take the derivative of sine, we know how to take the derivative of cos, and now we've seen tan. So if you've got an angle in the situation, most likely you've got a sine, cos, or tan question. The next type of trig question that can come up is where they give you all three sides of a single triangle. If there's a single triangle involved, it's probably Pythagorean theorem, or it's sine, cos, or tan, if it's only one triangle. If it's two triangles involved, can you see the two triangles? Let me draw one more thing in there. An orange line for the pumpkin man. The orange line, which is the height of the man. Yeah? Now he's really a stick man. Do you see this triangle here? And this triangle there? Now I got to rewind to grade 10, and it's usually not taught very well because there's too many other things important in grade 10 to spend much time on, which is similar triangles. It's the easiest of the trig, except you do so little of it that it becomes the hardest of it. So my job here, I always tell the grade 10 teachers, don't worry about it. When we need similar triangles, I'll teach it to them very quickly because you've got some more weapons available here. Let's talk about this angle here for a second. I'm not going to write it on there because I'm not giving it that much respect. But I just want to talk about that angle there. If I was using that angle to do tan on this angle, the tan of this angle would be h over 10. Can you see that? Opposite over adjacent. So I'm using tan to do similar triangles here, even though you don't need tan at all. But tan really helps. The relationship here means that h over 10, this height over this has to be the same as this because it's got the same angle. The tan also has to be the height of the man, 2, over this distance, which is however far away he is from the spotlight. Now, if you look at that and go, what are you talking about? I need to tell you, you just need to do a couple of similar triangle questions. It's actually the easiest of all the trig things that I've talked about today. Because all you got to do is look at the two triangles and go, okay, from this angle, opposite over adjacent must be the same as opposite over adjacent. Those two opposite over adjacents must be the same because tan has to be the same on both angles. And if you use tan or like that to do similar triangles, which is not the way they taught you to do it in grade 10, it makes similar triangles really super easy. Because this particular formula is not that big a problem, really. Right? I put a note online for this. And I have multiple choices here, and I want to make sure I do it the same way the picture shows online. Okay, isolate. I decided to isolate. Okay, I can isolate. That's not what I was going to do. All right, isolate. All right, here we go. Big mess. I want to take the derivative of, but it's not really ready to take the derivative of. So I'm just going to do some rearranging to get it ready. Okay? Cross multiply. And then isolate like this. Is that exactly what I did online? Oh no, I didn't do that. I just used hx equals 20. Okay, I like that better. Okay. You could do it this way. It's no problem doing it that way. I just want to match it up with the notes I've already done. Yeah, I like this because it makes me do product rule. Okay. The derivative with respect to time of this mess. Derivative of the first times the second plus derivative of the second times the first. I did that fast on purpose so you could see that it's just product rule. It's just what you've seen before, but there's a little more to the whole situation in that you've got h as an x and you're taking the derivative with respect to t. If you have a question. Yeah, I know. It's so tempting to use that 3 in there. What I need to say is that 3 isn't always 3. So I can't use it because it's not always 3. I can sub it in afterwards, but since it's not always 3, I can't use it. Whereas this distance, the spotlight to the wall, is always 10. So I can use it in my equation. Okay? Numbers that are only at a specific time, we only sub in when we're trying to do a calculation at a specific time. I'm making an equation that's true for all time. It is always true that h over 10 equals 2 over this x. Then I can take the derivative with respect to time because that equation is true for all times. It's a 3 at a certain time. It's a great question and a deep question. Okay, so what am I trying to calculate here? How fast is the shadow on the wall decreasing? That's dH/dt. That's what I'm trying to calculate is dH/dt. So when I don't have dH/dt, I don't panic. I do need x. And what is x at this specific time now that I'm trying to talk about? How long is this? 7. Yeah, a little bit of work there. That's what I was talking about. Sometimes you got to do a little thinking before you do your subbing. It's only a 7 there. dx/dt is how fast he's walking. 1.2. And the height of the shadow is, oh, I don't know the height of the shadow. How am I going to get the height of the shadow at this particular time? I got to go back to here. H over 10 equals 2 over, we decided the x was 7, yes? So I get H equals 20 over 7. A little bit of extra math, and then we'll see what you think of it all. Did I leave it on the fraction? Or did I go for the decimal? No, I left it as a fraction. Good for me. Oh, good. Okay, you must have questions because of the similar triangle nature of this question, I actually find these harder to teach and learn than the Pythagorean theorem one because it's a lot simpler. It doesn't have 2x dx dt, 2y dy dt, 2e. It doesn't have all that stuff in it, but you really got to get the similar triangle stuff, which again, we don't do enough work on in grade 10. And even if we did, it's 2 full years ago that you did similar triangles. Oh, Mr. Zeman, how are you? Yeah, sure. What questions do you have about that? I want to answer your questions about this one because I think it's the one in the homework. The other ones, if you just practice them, you're okay, where these ones are a little bit of trouble. So I want to answer your questions about them if you do have questions about these ones. You're either good or your brain's exploded at this point and you're like, oh, I'm going to have to figure this out later. Huh? More time on this one? I can't tell. Is it like we're mostly, this is pretty good actually, or it's like, no, I don't even know. I'm gonna have to frame my questions later. How is it? Tell me. Questions. What do we got? Therefore, the shadow is decreasing at negative 24 over 49 meters per second. Some people would say, no, you already said decreasing, you don't need the negative there. But I've seen people argue this back and forth to the point where I'm like, I'll take it. If you know it's decreasing and you write negative, we know what we're talking about. If you write decreasing and positive, I'm like, I think you covered it. Yeah, okay. Other questions? Last example. More time? A water flows into a bathtub at a rate of 20 liters per minute, and the level rises 0.1 centimeters for each liter added. Find the rate of change of height of the water with respect to time. This question is unbelievably difficult, except it's so darn easy. I need to show you something about it, because when you first see this, you're like, wait a minute, I don't know the shape of the bathtub. I don't know anything about the situation. How can it be? There's no way they gave me enough information. So I'm just going to write one important, actually I'm going to label each of these things, and I'm going to write one important line which is so good, and you're going to go from skeptical about Leibniz notation to loving Leibniz notation in one example. Okay, what is this? This is the water flowing in at a rate of 20 liters per minute. So it's the change of the volume of water over time. We call that dV/dt. Next, they said the level is rising 0.1 centimeters for each liter added. This is DHDV. Yeah. And they want DHDT. Really hard. Really hard. I need an equation that relates DHDT, dVdt, and DHDV. So hard. Let me write them all together. DHDT. What's the next one? DHDV. dVdt. I sort of acted like I was writing them out randomly. I wasn't. I sort of write them all beside each other to see everything that's going on there. Oh, there's hands. I'm off the chart impressed that there's hands coming up. Just look at it for another minute before you hear the answer, because I really want it to sink in. Because actually, weirdly, in a situation like this, the brain research tells you anybody who's out there is just staring at this going, I don't get it, I don't get it. They're going to learn the most in the next few seconds. If you're focused in, if you're like, I'll just write it down, I'll figure it out later, you're not going to learn anything here. People who know the answer, weirdly, aren't going to learn anything here. But the people who are looking at it going, what? How can these three things be related? Apparently, simply, the way he's acting, is that there's a simple relationship here. So let your brain really stare at that for a second, and then we need the answer. The hands disappeared. Did I talk you out of it? Brad, what do you think? He said it perfectly. He said it perfectly. And when you see it, hopefully you'll go from, I don't get it at all, to, oh, that's so nice. I love Leibniz, even though he's been dead for hundreds of years. DHDT is DHDV times dVdt. Why? Because the volumes, the dVs, cancel. There's one in the numerator, one in the denominator. See, it makes derivatives sort of work like fractions. And it's legitimate, actually. This would be V2 minus V1. This would be V2 minus V1. The V2s minus V1s would disappear. And all I'd be left with is the H2 minus H1 over the T2 minus T1. It's all legitimate, except it feels like cheating. Sal says, isn't this just chain rule? It is chain rule. And chain rule explained in a new way. You want to know how much the height is changing with time? Find out how much the height is changing with volume, and just multiply that by how much the volume is changing with time. Of course it is that. Not of course it is that. If it all got confused in your brain, don't be like, what do you mean, of course? You're throwing in of course in the middle of this? No, it's not of course. But there is a level of understanding where you go, oh. It really, chain rule's nothing. Chain rule's this, again, with the train. If I'm on a train that's going 100 kilometers an hour, I'll be moving 100 kilometers an hour, I'll be waving as I go by. But if I'm also on the train, walking 10 kilometers an hour on the train, I've got to put those two things together. It's not a perfect analogy, but it's really close to perfect in that this is just chain rule. So labeling these things with their derivative notation really helps. Then DHDT, get this, DHDT, the change in height with respect to time, is the change in height with respect to volume, which is 0.1 centimeters, multiplied by the change in volume with respect to time. Oh, wait a minute. Let me write down the units to really tie together what Brad said. 0.1 centimeters per liter. And if you didn't understand it a minute ago, the units might help you. This is 0.1 centimeters per liter times 20 liters per minute. I'm going to multiply these together and get a 2. Really dramatic number, 2. But what's the units here? Take a look what happens with the units. It's happening with the units, and it's also happening with the derivatives, and it also is just the chain rule. the lititers cancel, and I'm left with centimeters per minute. Hopefully proving that now units are, they're not the end of the question anymore. They're almost the beginning of the question. You're like, what are the units in this question? What am I trying to answer here? What do I want to know with the units first? Questions about that? Scary, unbelievably easy question. Huh? Clever. Clever little picture there on the card there. It's a chain. Is it? Chain really? Hmm? Yeah.